Okay, I think the participants have tapered off. So hello everyone from around the world, wherever you may be, and welcome to the Software Support Systems, the first session of which. In this session, we will have 3 different presentations. The first of which is by Andre, who is accompanied by Stephen at the moment. And they're going to be talking about a forecasting website that they've developed to help make business forecasting accessible around the community. So go ahead, George, and let's give it a listen.
Good day, everyone. My name is Andrei Vasnev, and today, together with Steven, I will show you our new project live and can be found on the following video. Well, before we go to the live demonstration, I just want to explain you why we embarked on this project to begin with. So first of all, we noted that, well, there are a lot of components that's already freely available to everyone. So we have lots of data available online and easy to get for everyone. Lots of simple forecasting methods are common knowledge as well. And there are free textbook, there are free packages in R and Python that can do forecasts for you. What we also know from the latest Info competition is that, well, simple models, they still do quite well. Well, there are more complicated models that improve their performance, but as benchmarks, those simple models are absolutely fantastic. And yet, it's difficult to get for an average person a reliable forecast of commonly used time series. For example, if you ask what is inflation going to be in the next quarter, well, I need to run a file, I need to run a program, I need to update my files in order to give this simple answer. So here, what I put it in the picture is that it's very easy to combine 1, 2, and 3, but yet kind of there is a huge bump to get to the forecast. So that's motivated our project, and we embarked on our mission. Well, first of all, make our life a little bit easier, so when people do ask us about inflation forecast for the next quarter, we can easily show this. But it became much bigger than this. So our mission is essentially to make forecasting models accessible to everyone, even people who do not necessarily know how to use R or Python, and to provide the latest economic and financial forecast of the commonly used time series. So our proposed solution is open source forecasting website, and it was kind of obvious for us that it has to be on the website because that's usually how people get their data. So it would be good to have forecasting in a similar format. And we are huge fans of open source, open textbook, or open R and Python packages. So we really wanted to keep it open source as well. So Stephen will give you a live demonstration of our website, and what we hope to achieve with this website is actually to smooth the bump, and everyone can actually enjoy the benefits of all publicly available knowledge and can get easily to the forecast whenever they need to. Over to you, Stephen.
Thanks, Andre. So I'll go over a quick tour of the website and then have a brief discussion about how the website is run at a system level. So firstly, this is the website homepage. At the top, you can see the navigation bar and then our mission statement, and then underneath that follows our features sections. So we have a featured series, and we have information about latest news, and then corresponding snapshots for different countries or areas of interest. So the website is designed so that we can actually mix and match these different components. And so over time, we will adjust what's shown on the homepage based on what's currently happening around the world. So at the moment, our featured series is Australian unemployment because that's something that's been heavily affected by COVID-19. The latest news information here, that just comes from our blog, and our blog will be updated with news about new series that we've added or new forecast methods or maybe just general changes to the website. Some examples of different countries. At the moment, we mostly have Australia, US and UK data listed, but that is subject to change, and we encourage everyone to contribute different series from around the world if they can. So US snapshot, and then US unemployment is featured, and then an Australian snapshot and a UK snapshot. From here, you can click on any of these series and it will take you to the series page. On this page, you can find a bigger version of the graph thumbnail that was shown on the home page. From here, you can select different time periods to view the series from. So by default, we only show the past 5 years worth of data. At the top left, you can select 5 years, 10 years, or all. So this is showing all the data for all historical data for Australian unemployment. And you can also adjust the slider down the bottom as well, so to have a range to your liking. Underneath that, you can select the different forecast method. So by default, the forecast that is shown will be from the forecast method which we've determined is optimal via our backtesting method. So you can use this drop-down box to choose a different forecasting method if you like. So at the moment, it's set to the combination M4 benchmark, and that's marked as the best model. So if we wanted to look at what the AutoArima model, what forecast was produced by the AutoArima model, you can click that and the page will update and you can see the forecast has changed. Underneath that, you can see some information about the model details, including the cross-validation score that we used to compare the different methods, when it was updated and when the data was collected last. You can also see the original source of the data. So we've given a direct link to where we got this data from. So you can go to that data and if you want, check it out yourself. Over on the right-hand side, we have a tabular version of the forecast. So you can either select from this drop-down box the forecasted values or the different confidence intervals. And if you prefer to look at this in a tabular data form. Now, if you want to find a particular series or search for a series, you can click the Find a Series link at the top, and that will take you to the filter or search page. You can filter or search your series by name or tag, and you can also search by winning method. So I'll give you an example of the sorts of things you can do. So if you're interested in finding the series associated with inflation, so you can type inflation, and then there are 3 results found. There's Australian, UK, and US inflation so far. If you're only interested in Australia, for example, you can click the Australia tag, and that will limit the results to those associated with Australia. If you're interested in finding series where the winning method was a particular method, you can then tick any of these boxes. So if you're interested in finding all the series where combination M4 benchmark was the winning method, you can tick this box, and we can see that for these 3 series, the combination M4 benchmark was selected as the best method to use. Another interesting page might be the leaderboard page. So this page shows you how many times each method was selected as the optimal method over all the data or all the series available. So you can see that the naive method was selected as the optimal method 4 times. So if you click this link, it will take you back to that filter page and the results will be filtered by the series where naive was the best method. Something to be aware of with the leaderboard page, don't take this as gospel that the naive method is the best method of all forecasting methods. This is just limited to our particular backtesting method or methodology and also the data sets that we've used. So as we increase the number of data sets or series that are involved, we expect this leaderboard to change, and we will probably make some adjustments to our backtesting method in the future. I'd like to give a quick overview of how the system is designed. Most of our system is built using Python, There are two main components. There's the updater and the web server. These are two containers inside a Docker environment. The updater will run at 3 a.m. every morning, and it will download all the series data and then run the forecasting methods against each series. Now, we use a variety of forecasting methods. So most of them come from the forecast package in R, which we access through the RPy2 library. So we can actually call R functions directly from Python. We have other ones from scikit-learn, and we expect that in the future we will be able to use libraries like PyTorch, etc. The web server is quite straightforward, much simpler in comparison in terms of explaining things, but it's still quite a lot of code going on the web server side of things. But the main two components of the web server are Green Unicorn, which is the web server, and then Plotly Dash. Now, Plotly Dash is a way to build interactive dashboards, and what you see on the website is entirely built on Plotly Dash. Every interactive component, in fact, all components on the website are some sort of Plotly Dash component, and that's entirely written in Python. We haven't had to write any CSS or JavaScript ourselves, which is really great. So if you're unfamiliar with Plotly Dash, I highly recommend you use it for dashboarding applications, and it also really works really well for website development, particularly this sort of thing that we're doing here with our forecasting website. So that concludes the overview of the website functionality and system architecture, and I'll hand it back over to Andre.
Thank you very much, Stephen, for this amazing presentation. So a couple of concluding words from me is that our mission is for this project to become a community project in a way. So we have a live prototype, and by making this an open project, we hope to involve the forecasting community in further development. So if you want to add more series or new methods, so please feel free to submit your suggestions or your code on GitHub. And here are the links. Obviously, our website is here. So our GitHub repository is freely available to everyone. And if you want to correct a bug, if you find one, or add a series, or propose a new method to be added, so you can easily submit a suggestion here as well. And if this is not sufficient, here are our emails, so feel free to send us an email if you need to. And of course, it's a big project, so there are many people involved in it, and it was a tremendous effort. It was a tremendous team effort, and many people worked overtime, and they used their free time to push this project to this stage. So I hope that you agree with me that it is looking really good at this moment. So thank you very much for your attention, and I hope you benefit from this website as much as we do. Thank you very much.
Fantastic. Thank you. Does anyone have questions? Feel free to unmute your mic or ask a question in the chat if you have one.
There is a question in the chat. What format is the data?
Is that in terms of what exactly? The configuration? Well, so at the moment, when the website updater runs, we have a JSON list of all the data sources. Most of the APIs that we access give us a CSV file, but we can tailor that to basically access almost any form of data that you can easily do in Python or R. So if it's publicly available on the web, you can probably integrate it somehow with our website. and it would be easiest if it's a CSV file.
Yes, small question. Thanks for the presentation, Andrew. Yeah, so my question is, so the website at the moment are they mostly, you mean the time series that you are working at the moment are mostly common with macroeconomic data, right? I mean, have you tried with some data set? For example, you take the M3 competition data set and you do everything. I mean, you basically visualize everything that you have done. You have benchmark data sets, benchmark methods, and you compare the errors. Have you thought about it? I mean, it's like it's like instead of having a one-time series, you basically have 1,000 time series, or something like that. Have you thought about it?
Well, thank you for this suggestion. I think the short answer, we didn't think about it. And I think the reason why we didn't think about it is because we wanted to make it kind of a product that everyone can use in the real life. So it's really the data that we have, it's all live. An example is, well, if there is an update on the Australian unemployment today, you will see it on our website tomorrow. So all data is live. But in principle, of course, we can suck any data we want. Just kind of try to think maybe we can have a portion of the website where we have M3 or M4 data, which is not necessarily live, but where you can check that all the model that you run, you get the same results as in the competitions as well. Thank you.
I see.
For the suggestion.
No worries. Thank you.
Okay, I think we've got time for one more question.
Hi, Andre. It's Ryan here.
Hey, Ryan.
Just wondering about the training sampling scheme. Do you fit for example, the ARIMA over the whole period of the days available? Like, for example, unemployment going back to the 60s or 70s? Or do you use a rolling window?
Stephen?
So we backtest at the moment all the way back as long as the series goes, but we use the forecast window is fixed at the moment to 8 intervals, and we're planning to update that based on the frequency of the series and adjusting it basically on a per series level. So we do have the flexibility to choose what the forecast lengths are at a per series level if we choose to. We just hadn't had time to fully implement that yet. I'm not sure if that is that question.
Yep, that's right.
So I think in the forecasting world, the window that we use is rolling, and it's kind of rolls all the way to the beginning of the data set. And that's kind of something which we did pretty quick, but I think we are very open to all the suggestions how we can build something which is robust, but also unique, gives a useful insight for a particular time series. Thanks.
Fantastic. Thank you again for your talk and great answering of the questions. I pass over hosting duties to George for my own presentation.
Mitch, you've got 20 minutes.
Okay, let's see how we go. Hello, everyone. I am Mitch, and today I'm talking about Fable. You may have heard of the Fable package before. If you haven't, I'll go over some of the basics. But the big new thing, the big new feature in Fable that I'd like to talk to you about today is cross-temporal hierarchies and how you would do probabilistic reconciliation within Fable. Here is my information. You can talk to me on Twitter, or you can access the slides at the link below. Actually, I'll put this in the chat if you'd like to follow along. Okay, so hello everyone. If we've got anyone from Europe, I'd be very impressed, but no matter where you are in the world, thank you for coming along, and good morning, good afternoon, or good night, depending on where you are. And let's talk about time series. Now, before I do introduce some of the things here, I will say that this is a presentation that has driven a lot of development in the area for the Fable package. And for the temporal stuff that you'll see, think of it as a bit of a proof of concept. You can access it from the temporal branch of Fable tools. However, everything is subject to change, but the main ideas of what will be possible should be coming soon. So you might see this little GIF from the 90s on the internet come up just to signify where things might be changing in the future. So let's start by thinking about what is Fable if you haven't seen it before. Well, given that this is a forecasting conference, you may think that it's something to do with forecasting, and you'd be right. But to know about Fable, you need to know about a few other packages as well. Fable builds on top of a time series class called Sybil. Sybil is for time series data in a tidy Tibble format. And there's a few other packages that build on it. Sybil data providing some example data sets, and Feasts providing some features and statistics for time series. So this is what a Tibble looks like. You can see it's very similar to a data frame or a Tibble if you've used R before, except there's a slight difference that, similar to Rob indicated in his keynote, we've got some concept of time in this Tibble. So in particular, it knows that the data is quarterly, and that's because it looks at the quarter column that you declare and sees that this is a quarterly data set with quarterly interval. Every time step, every increment in time increments by a single quarter. Additionally, there are 3 keys. Keys are used to uniquely identify a time series in a Tibble. So in this case, we have combinations of regions and states, and also the purpose of some domestic tourism in Australia. So in 1998 quarter 1, there were 135, I think thousands is the units here, trips domestically for business trips to Adelaide, which is in South Australia. In total, 304 time series in this data set. Not the focus of the talk, but I think it's useful to understand the data a little bit. We can use the Feasts package to compute some features. In this case, we're computing features based on an STL decomposition so that we can get a sense of the trend strength and the seasonal strength, how strong the trend and seasonality is for each of these 304 series. If we plotted these series using some ggplot code, and this highlights the integration between Sybil and Fable with the tidyverse, you can see that there's some interesting structure here, notably the holiday pattern. On the y-axis, we have seasonal strength. There's a lot more seasonal series for the holiday purpose of travel. Let's see how Sybil works with dplyr. So we'll start by taking these 304 series and slicing and dicing it a little bit so that we focus on a single series. In particular here, I've filtered the purpose to be holiday tourism only. And then I've summarized the total trips over the region and the state. So here we've got the total number of holiday domestic tourism across all of Australia, and we can plot it using autoplot. Now you'll note that the Sybil has no quarters, no keys, should I say, because it's a single time series. Okay, onto the main topic, Fable. How do we produce forecasts? Well, we start by looking at the data. We've done that already. And we can produce a model, a Fable model, using the model function with a model specification. So here I've declared that I'm going to use an ETS model to estimate the trips variable, and it will automatically select the appropriate ETS model. In this case, an MNM model, so no trend and multiplicative seasonality. We can then use the forecast function with a specification of the horizon, which can be specified in human terminology by passing a string. So 3 years ahead, we get a Fable now, a forecasting table, which looks very similar to a Sybil. The only difference being, you've still got the interval here and the key structure. The only difference is that a Fable contains a distribution. So you can see the Fable package, when you produce forecasts, you get probabilistic forecasts. It gives you the entire forecast distribution. We can, of course, then plot those forecasts. We use the autoplot function and provide the historical data to get a plot of the history along with the forecasts from that distribution. So how do we talk about hierarchical series? So the key topic of this is reconciliation for this talk and how Fable helps with reconciliation. And in Fable, to aggregate a hierarchy, we use the aggregate key function. Remember, keys are the columns that identify each series, and we want to aggregate over them. So you take the data, you pass it to aggregate key, and then you provide a key specification. In this case, we are specifying that the group A variable, this second row, second level in the hierarchy, is going to nest group B, the third level. And the way in which we compute our variables across this hierarchy, in order to take these bottom level series, the 304 that we had, and add them together to give you aggregates, we're going to sum the response variable. So when you do this with the tourism data set, we're going to do a small example just so it's easier to look at, but this can extend to the entire data set with all three keys. Let's consider tourism split up by states. So in this case, we're only going to aggregate a single variable and we're going to ignore all of the other ones. So we're going to take the tourism data and aggregate by the state variable. And the trips column is the observations that we're interested in forecasting. So we're going to sum them up. In other cases, maybe you have a logical variable for if it's a holiday or something. You may want to use a different function from sum. However, currently the response variable needs to be summed because reconciliation is an additive aggregation process. So this gives you a Sybil again. However, now you can see in the state variable, there's normally 8 states in Australia in this data set. We now have an aggregated value giving us 9 states in total, and they're plotted on the side. So you can see at the very top level, this red line is the aggregated data. We can use the same interface as before, taking that aggregated data and produce the same code to produce a model and then forecast it 3 steps ahead. And now we've got forecasts for each of those time series, each of the states and the total for Australia with our distributions as before. However, there's an issue. These time series, these forecasts won't necessarily add up because each of the underlying models are doing their own thing. So that's where reconciliation comes in. So you can use the reconcile function and specify, this kind of modifies the model in some way. Then you can specify a reconciliation method. In this case, I'm using optimal reconciliation using minimum trace. I'm using that method on the ETS models to produce a new model, which will be min-t, min-trace, reconciled version of the ETS model. And we can then forecast that again. Notice because I've given this a different name, I'm actually getting 2 models in the resulting fable. One which is our base forecast for ETS, and another which is our reconciled ETS forecasts. And on the side here, it's a little bit small, but you can see slight deviations between the 2 forecasts because of that. And theory suggests that the forecast accuracy will be improved as part of this reconciliation process. Now for the new stuff. So that was all that I talked about last year at ISF 2019. Let's have a look at the new features in Fable, which is forecasting temporal granularities. So before we were aggregating the key variable, this time we're going to aggregate the index. Once again, this is a brand new code and probably has some issues with it, but they will get fixed. This is more of a proposed interface for how it will work. And we've got a proof of concept of it working a bit later. So the interface is very similar. We require a new package called Moment. Moment handles temporal granularities. So some data, some parts of the data might have a year. Every next observation increments by 1 year. Others might be semi-annual, so 2 quarters is the increment, 1 quarter, and so on. But the same interface applies where you need to specify how the variables in the data will aggregate. So this is how you would write the code to produce this tree structure. The TU year, time unit for years, gives you this annual series, semi-annual, the quarterly in yellow, and the monthly in green at the bottom. Let's see this on the holiday dataset, the tourism. So taking that Australian holiday, the single series from the start of the talk, we pass that into aggregate key, and I'll take compute annual, semi-annual, and quarterly aggregates by summing up trips. And you can see this Sybil now looks slightly different. We actually have 3 intervals in this data set because the data contains 3 different temporal granularities. We have annual, semi-annual, and quarterly. With this preview of the data, there's now more observations. We can't see the semi-annual and the quarterly data, but you can see that the class of this column is now a moment from the moment package. And on the right, you can see the plot showing the green line is the annual aggregates. And as you disaggregate from annual, you start to see some of the seasonality coming through. Okay, we can then forecast this much the same as the theme before. You use the same code to produce models and forecasts. ETS model for each of those temporal aggregates, forecasting 3 years ahead. We now get a fable with those 3 intervals. And here, because there's less observations, less forecasts that we've produced, you can see the time interval is actually mixed. The granularity is mixed between years, semi-annual, and quarters. On the right, you can see the forecast plot of that. Do note that there is a slight bug in the code at the moment. It's all very fresh code. This 2 quarterly forecasts should be squished a little bit more. So it all should line up, but the numerical results, the distributions are all correct. Okay, so that was the base forecasts. Now, how do we do temporal forecast reconciliation or temporal reconciliation of our forecasts? The exact same process. So we specify that we're going to use the minimum trace reconciliation technique on the ETS model and then produce our forecasts. And now we have the same fable, except the resulting distributions are now coherent, meaning that the months will add up to the quarters, which will add up to the semi-annual, which will add up to the annual. And you can see the somewhat substantial differences in the forecasts on the right. So you can see the blue line is the coherent forecasts. The red line below is the base forecasts. This trend in the annual series has been put into it by the structure observed at the bottom granularities. Okay, now for the big one, cross-temporal forecast reconciliation. So just think to yourself, we know how to do cross-sectional reconciliation. We know how to do temporal reconciliation. How do we do both? This is a pretty hot topic at the moment. And in Fable, brand new code, you just join the 2 processes together. So you first aggregate the key structure, and then you aggregate the index. So here's how that relates to the symbolic graphs before. The aggregate key step will produce the graph on the left. And then I haven't produced a specific graphic for this. Thanks, Rob, for the plots for these graphics. However, if you apply aggregate index on top of an aggregate key, you can imagine each of these nodes on the left side will be represented by this node structure on the right. So within total, you then disaggregate it into annual, semi-annual, and quarterly, and so on. And under the node A, you will do the same and for every node on that key disaggregation. So here it is applied to the tourism dataset. I'm going to keep the number of series low here, but it should maybe, hopefully, work if you applied it to the entire thing. Again, all under development at the moment. But first we will aggregate over purpose. So there's 4 reasons to travel domestically. We have business, holiday, and other. Business, holiday, other, and visiting, should I say. And then this aggregation is producing the aggregated values as well. And then for this, each of these series, we then aggregate the index. So we have 1998 and the first, and the quarters within that as separate series, keeping it the number of series short so that we only have a few to look at, in this case, 10. And this is what we see on the side. So these smooth lines are the annual series. There's no seasonality. And the slightly bumpier series here are the quarterly. And George has just let me know that these graphs here are George's. So thank you, George. Okay, so we can forecast in the exact same way to do cross-temporal forecasts. In this case, we're doing them separately. So there's no reconciliation here and we won't get coherent forecasts. But the same interface applies, fit a model, produce some forecasts, and you can plot them. And once again, to reconcile cross-temporally, which is pretty exciting, you just add in this reconcile step, and then the forecasts will be coherent. So you can see on the annual aggregations, the blue lines is the reconciled, and they're imparting a trend on this series. Okay, so here's the summary. First of all, we have a tidy temporal data set suitable for forecasting many series and working with the tidyverse. We can aggregate both cross-sectionally and temporally with help from the new moment package. We can fit any model to this temporal and cross-sectional disaggregated dataset or aggregated dataset using Fable. This can also be like combinations. You can do an ensemble here. You can let your imagination go wild. There's a single function to reconcile any type of disaggregation, be it temporal or cross-sectional, and you forecast it simply. Thank you everyone. Special thanks to George for the contributions and the discussion on how temporal reconciliation should work. Thank you to Rob, thank you to Eero, thank you to everyone in the department and everyone that's been involved in the thought process of getting this into the software. I'll open it up to questions. Thank you so much.
Thanks for the presentation, Mitch. So I have two questions actually. So first question is whether the moment package, is it very similar to the Thief package? I mean at least the underlying the implementation, is it very similar to Thief or is it something different? And the second question is whether actually that's relevant to the reconcile, the HTS package as well. I mean, do you guys have the function, for example, if you want to do the a different method for different level hierarchies, right? So you have in the HTS package, you have the combine F function, but in the new package, do you provide that capability so you can apply different methods for different hierarchies and then finally combine using the combine F? Is that possible in the new package as well? Thank you.
Yeah, so when you produce a model, I'll find an example of that. When you produce, oh, that's not a good example. Oh, there's no examples here. When you produce a model and you get a Mabel, each row will identify a separate series.
Okay.
And you could slice and dice this Mabel to use models from anywhere you choose. So you can control the model of every node in the hierarchy as you please. I do need to add in some functionality to conditionally model based on the input data. That will come when it gets here. But for now, you can filter and join and bind rows, whatever you need to do to make your models in the structure you want.
So for different, even for the temporal aggregation, you can use for different temporal levels, you can apply different methods and then finally combine together, right?
Exactly. So it all works with the data. You get a Sybil, and then from that Sybil, when you model it, this is model and forecast, but you'll get a separate model for each temporal split. So you can filter out the ones that you want to keep and use whatever one for any series. Regarding the moment question, it's not related to Thief at all. All that Moment does, and the name is pending. If you have better ideas for the name, do let me know, because this is confusing with distributional moments. All this does is makes it possible to store mixed granularities in a vector. So here we have quarters and months in the same vector. All of the reconciliation stuff is handled by Fable tools. But for the interface to work and for you to get a single data set, the moment package is particularly important there.
All right. Okay. Thank you very much.
Thank you. And there's a question from Ryan. Would swapping the aggregation order yield a different result? It's something that I haven't tried, but we can think about it briefly now. So if we have, this is all very fresh code, and I'm not sure if it would work yet. So if you took your data set and then you temporally aggregated it, I have a feeling that it should work. Simply because each different temporal set will be a new key. However, the temporal identifier, like semi-annual or so on, will need to come into this specification somehow. So in particular, the group A/group B identifies these series. Then you'd need to group that with some brackets and then have a nesting within each of those series. I can write it up here. So group A/group B will need to be entirely nested by some identifier for the time unit. you'd need to add in some interval key structure to identify if it's quarterly or annual or monthly. But it's probably easiest to just do keys first and then indices. Okay, George isn't cutting me off, but I think I've run through my 20 minutes. I'll finish up there. Thank you for your questions.
Sorry, Mitch, I was enjoying your presentation. So yes, you did run over 2 minutes.
Thank you for hosting, George. Next up, we have Tianga. Tianga was studying at Monash University and now is in Sri Lanka studying or being a lecturer there. And she'll be talking about a new tool to detect potential data leaks. So take it away, George. You can start the video.
To rank the submissions. I'm Tianga Thalaga. In this presentation, I'm going to introduce a new R package for detecting data leakages in forecasting competitions. Forecasting competitions have played a significant role in the advancement of methodologies and techniques for solving various forecasting problems. Over the past few years, forecasting competitions have proven to be a valuable and effective approach to learn best practices and gain knowledge. There are three main steps involved in the process of organizing a forecasting competition. First, data collection. Second, process data and set forecasting tasks. Finally, evaluate forecasts to rank the submissions. Usually, the data set of a time series forecasting competition is a collection of various time series. All series in the collection are divided into a training period and a test period. The test period set or the test period is kept in reserve so that genuine out-of-sample forecasts can be made and compared with the actual observations. Hence, the test set is not accessible to participants during the competition to avoid possible overfitting of the methods. This test set is used to measure the accuracy of forecasting results and rank the submissions. However, there could be situations the training data contains information about the test data. Here is an example. I have two series. Each series is split into a training set and a test set. You can see in this example the last part of the training period of the first series repeats here in the second series. Hence, the subsequent part could be the test period of the first time series. In this example, it actually does. This is called data leakage. The training data contains the ground truth. Data leakage happens especially where a lot of time series is involved. Data leakage is a common problem. However, it is widely underestimated. Data leakages can be presented in different formats. I'll show you some examples from recent forecasting competitions. Two time series from the M1 competition. The series IDs are QRC2 and QNC18. A subset of the bottom series was used to create the series on the top. These are the actual values. This section in QN18 is the training set of QRC2. The last part of the training set in QN18 becomes the test period of QRC2. Here is another one from the M4 competition. Daily time series D40, the daily time series D44, repeating patterns. Again from the M4 competition, two daily time series D101 and D102. They look the same, the only difference is the scale of y-axis. The top series is created by adding a constant to the series in the bottom. These data leakages could happen both at the data collection stage or data processing stage. For example, when downloading data from different databases, it is possible for some of the series to overlap, or when adding a constant values to protect data privacy issues. Hence, it is important to identify these duplicates in the data set. Methodology. This is a simple algorithm to detect data leaks. The algorithm is mainly based on Pearson's correlation coefficient. This is a visual demonstration on how it works. Each row represents a time series. Green color section denotes the training period, and orange color for the test period. Let's start with the algorithm. Here, I consider the most recent observed values of the training period of the first time series. Window size equals to the length of the test period. Users can change the window size according to the features of the data. After that, this section slides across all series, including itself, to find highly correlated subsections. First, compute the correlation between these two, and next, these two. Likewise, you can go over the whole time series and come to the next one. Suppose at this position, the correlation coefficient is 1. That means they are perfectly correlated. Then, this red color section could contain some information about the test set of the first time series. Similarly, we slide all of these sections across all time series in the collection to spot duplicates. This algorithm is implemented in TS Data Leaks package. In order to demonstrate package functionalities, I created a small time series collection. This is the visual representation of the simulated time series collection. These are series ID, series A, B, C, D, E, F, G, H. The ash color section appears 3 times in the whole collection. Inside series E, this section is much darker than other ash color sections. That means a constant value is also added to the observed values in the ash colors subsection when creating the series E. Inside series G, yellow color section is repeated twice. Inside series I, ash color section is repeated twice. The main function in this package is find data leaks. The first input is the list of time series. Second input is window size. Here is the output. The output says the last part of the training period of series A perfectly correlates with the observations from 1 to 6 in the series C. That's here. This one with the observations here. Next function is with data leaks. This is to visualize the results of find data leaks using a tile map like this. Here, the last part of the training set of series A perfectly correlates with single subsection of series C. Here the color is yellow, count is 2. This says the last part of the training set of series A perfectly correlates with 2 subsections of series I. That's one here and one here. Next, identify reasons behind data leaks. For that, I compute one-to-one differences between the points. If the mean value of the differences is 0 and the standard deviation is 0, it is an exact match. If mean is not 0 and standard deviation is 0, then a constant is added to the subsection when creating the new time series. Let's now apply this to yearly series in the M1 competition. This is the visualization of data duplicates in M1 yearly time series. However, some of these duplicates are not useful. For example, here, YAM28 and YAI21. YAM28 and YAI21. In this situation, training set does not contain test data information. So this duplicate is not a data leakage. This is just the same series appear twice in the collection. So that's what we have here. In the M1 competition, for yearly time series, there are only 3 useful data leakages. This plot displays the reasons for data leakages. For example, if you go back, only these 3 are useful. The reason for this one, that's YAM2 and YAB3. Those subsections are exact match of those subsections. YAB4 and YAM1, again exact match. Here in this case, blue color represents a reason unknown. If you observe the 2 time series, that's YAG29 and YAC50, they have an increasing trend. This subsection is used to create this time series. Exploiting data leakages do not bring you luck always. Here is an example. YAB3, YAM2 in the M1 competition. YAB3 and YAM2, this one here. First few observations are the same, up to this one here and up to this one here. They are the same. However, these 3 and this one, if we compare these 2, the test set values are a little bit different to the values here. Exploiting data leakages are useful before the competition for the organizers to avoid data leakages. During the competition for the participants to reduce forecast error and improve leaderboard rankings. Furthermore, after the competition, that's for the entire research community, later these data sets become benchmark data sets to evaluate new forecasting approaches. Hence, it is always good to have an idea about the quality of the data sets. Feature bar, use time series feature space to reduce the computational time of the algorithm. Here, the feature space is created based on two features. X-axis is strength of trend, Y-axis is CF1 of the first difference series. Each point represents a time series. In this case, we have yearly series of M1 competition data. You can see the corresponding duplicate series lie very close to each other. Here, YAB3 and YAM2. In this case, YAG29 and YAC15. Hence, rather than computing correlations across all other series, this feature information can be used to restrict the domain. That brings my presentation to the end. Thank you.
Okay, thank you, Tianga. Do we have any questions? Got a couple of minutes. Once again, you can put your questions in the chat if you have any, or you can unmute your mic and ask directly.
I think a small question. By any chance, did you look into the M5 dataset and check whether there are any data leakages there?
No, I didn't check the M5 competition because at the moment the package is very slow.
I see.
But we checked for the M4 competition. M4 competition daily time series contains substantial amount of data leakages.
Awesome. Okay, thanks.
Is there another question? Okay, fantastic. Thank you very much, everyone, for coming. Thank you, Tianga, for your presentation. Next up, in a different session, we have Forecast Evaluation 2, if you wanted to move along to there. Otherwise, thank you for coming along to the Software and Support Systems session, and see you at the rest of the conference.